We're going to begin our discussion of statistics with a conversation about statistical and critical thinking. It's really important that when you think about statistics, you're not thinking about trying to just do one computation on a piece of paper and then being done with it. Statistics is bigger than that. So when we want to have a statistical study, what we do for that is we prepare, and then we analyze, and then we conclude. It's a three-part process. So we're going to explore what that three-part process is and what those pieces actually mean a little bit later. But before we jump into it, we need a little bit of vocabulary that we're going to be throwing around a lot. The first one is data. When we talk about data, we're talking about collections of observations. These can be just about anything, and there's multiple types of data, so we'll need to be able to classify types of data. That's something else we'll discuss a little bit later on. Also, statistics. When we talk about studying statistics, what we're studying is the science of planning studies and experiments, obtaining data and organizing, summarizing, presenting, analyzing, and interpreting those data, and then drawing conclusions based on them. Right? It's its entire field on its own. Another word that's going to come up a lot is population. When we talk about a population, we're talking about the complete collection of all measurements or data that are being considered. Hopefully is familiar to you when we've talked about populations of countries or something like that. We're talking about all of the people in the country. Well, the same here. We're talking about everyone, everything, all of the collection. All right. When we talk about conducting a census, which I'm sure you've heard that word since we just did our last census as a country last year, we're talking about collecting data from every member of a population. Conducting a census can be incredibly time-consuming and expensive, which is one of the reasons that we don't do it terribly often. Instead, we use samples a lot. A sample is a sub-collection of members selected from a population. And then we can find out stuff about the population based on that sample. We'll be talking more about that and ways that we can do that throughout the course. So let's take a look at an example. We have residential carbon monoxide detectors. The journal article, Residential Carbon Monoxide Detector Failure Rates in the United States. It is stated that there are 38 million carbon monoxide detectors installed in the United States. When 30 of them were randomly selected and tested, it was found that 12 of them failed to provide an alarm in hazardous carbon monoxide conditions. So, if we wanted to test the entire population here, we would be testing 38 million carbon monoxide detectors. That's pretty impractical for time and money concerns, all right? So what they did in this study is the population was all 38 million carbon monoxide detectors, but the sample was only those 30 that they tested. The objective of the study is to use the sample as a basis to draw a conclusion about the population of all carbon monoxide detectors. And statistics can help us do that. So this three-part process that I talked about a little bit earlier, here it is outlined. I love this graphic. All right. So when we prepare, what we're doing is we're thinking about the context. What do the data represent? What's the goal of the study? We're thinking about the source of the data. Where did it come from? Do we trust where it came from? Do they have some kind of interest that might have made them be incentivized to make the data not say one thing and say something else instead? What was the sampling method? did they randomly choose some people, or did they just go to the next person on the streets? There's lots of different sampling methods that we can use. Then, once we've thought about all of these things, we have this background information, we're ready to analyze. To analyze, a lot of times we'll graph the data, or we'll explore the data by looking to see, are there any outliers or data points that are way far away from the rest of the data? And how is it distributed? Is there anything misleading about it? Did any of the subjects refuse to respond or skip some questions? And then we'll apply statistical methods. A lot of times we use technology to help us with this. And then finally, we're ready to draw conclusions. In statistics, the conclusion that we draw is generally whether it's significant or not. So we check to see if the results are statistically significant. But then after that, we also think about if it's practically significant. So let's dive a little bit deeper into each of these three parts. So here's an example where we have pleasure boats and manatee fatalities from boat encounters. You have a table of data here, and we're going to think about this prepare step. Well, the first thing we're going to think about is the context. So the table has numbers of registered pleasure boats and manatee fatalities. All right. What is it wanting us to do? Well, the way it's paired up, it looks like for every number of registered pleasure boats we have a number of manatee fatalities to go with it. So we're wanting to know the relationship between these things. The source of the data is the Florida Department of Highway Safety and Motor Vehicles and the Florida Marine Research Institute. Those entities don't really have any super big incentive to make this study outcome be one way or another, and so we can trust that. And the sampling method, it's official government records in this case, which seem pretty sound, right? Something that can happen when we're doing our sampling, when we don't have this great case of like government records to go off of, is we can have voluntary response samples. You see these all the time, right? So a voluntary response sample or self-selected sample is one in which the respondents themselves decide whether or not to be included, right? So the following type of polls, we've got internet polls, mail-in polls, telephone phone calls, radio ads, anywhere where the person responding has to choose whether they're going to respond or not is a voluntary response sample. That might not seem like such a bad thing, and we see these polls all over the place, but let's take a look at what could happen when you have a voluntary response sample. So, Nightline asked viewers one time to call with their opinion about whether the UN headquarters should remain in the United States. Then the viewers had to decide whether they were actually going to call or not with their opinions. 67% of the 186,000 respondents said the UN should be moved out of the United States. But when an independent survey chose 500 respondents randomly and asked them, 38% of that group said the UN should move out of the United States. Those are very different responses. When you ask people to voluntarily respond, you tend to get people who feel very negatively about things responding at higher rates, and you only get people who feel very extremely about things responding. As a general rule, it's not always the case, but that happens and it biases the results. So consequently, even though there were 186,000 respondents for the Nightline poll, the one that randomly chose 500 respondents is probably a better idea of what the US population feels about keeping or leaving the UN headquarters in the United States. All right. So our next step after preparing is to analyze. So after we complete that preparation, we're going to analyze, we're going to graph and explore. Looking at the visual can give us an idea of what the data looks like. Then we're going to apply statistical methods. So we don't necessarily have to be super strong with computational skills in order to do a good statistical analysis. I really want you to internalize that. You can do this, all right? So a lot of it's paying attention, having some common sense, and yeah. All right. So after we've done that analysis, then we need to make conclusions. So we say something is statistically significant if there's a 5% chance or less of whatever the outcome was happening just by chance. We feel like that's a small enough percentage for it to be happening just by chance that we can say, you know what, there was probably something actually to this. All right. So here's an example of this. If we get 98 girls in 100 random births, that's statistically significant because it's so extreme, right? It's really not likely to happen by random chance. However, getting 52 girls in 100 births is not statistically significant because that happening by random chance is fairly likely. Then, once we have made a decision about the statistical significance based on this percentage that we calculate, we have this idea of practical significance. There are times when things are statistically significant and they're just not practically significant. They cost too much money. The outcome is really actually in practice not huge. So let's take a look at an example to see where something might be statistically but not practically significant. So ProCare Industries once supplied a product named Gender Choice that supposedly increased the chance of a couple having a baby with the gender that they desired. In the absence of any evidence of its effectiveness, the product was banned by the FDA as a gross deception of the consumer. Now, if it hadn't been banned, and they had instead done some kind of study on this, let's suppose that the product was tested with 10,000 couples who wanted to have baby girls. And the result consisted of 5,200 baby girls born in the 10,000 births. That result is statistically significant. The likelihood of it happening by chance is 0.003%. So chance is very unlikely to be why that happened, which means this ProCare Industries product, Gender Choice, actually probably was statistically significantly effective. But was it practical? Was it practically significant? So that's a 52% birth rate for girls. So 52% girls, it's statistically significant. 52% though versus the 50%, it's not actually that much difference for any given couple. So it would be very unlikely that couples would really see that difference of 2% increase and say, I want to spend money on this product and I want to spend time and any risks that it might have. It's just not worth it in practice. So this is an idea of this practically significant idea. You might have all kinds of things that fall into this category. This happens a decent amount with drug trials when we're trying to do something to cure some disease where the cost of generating the drug versus the effectiveness that it has is just not worth it. And so drug companies go back to the drawing board. All right. When we're analyzing data, there are pitfalls that we can fall into. The first one We have misleading conclusions. So when we're forming a conclusion based on our statistical analysis, we have to make statements that are clear, even to those who have no understanding of statistics or its terminology. Most of the people who will use our decisions, they don't understand statistics as well as you will at the end of this class. So you need to make sure that you're stating your conclusions clearly. Also, sample data reported instead of measured. When you ask someone what their weight is, or you instead have them put them on a scale, you're going to get different numbers. People self-report differently than what a measurement might be. So when we're collecting data from people, it's a lot more reliable if we can actually take measurements instead of asking them to report the results. Additionally, we can ask questions in a way that are very loaded. What I mean by that is we can make people think that they should respond one way. You might do this unconsciously in your conversations with your friends and family by starting a sentence with, "Don't you think?" Right? When you hear that, it's like, well, of course I should think that. That's a thing that we can do when we write questions. We do it unconsciously sometimes, and it makes people prone to answer the question in any given way instead of the way that they would naturally answer it otherwise. So we have to be careful about how we word questions. Additionally, we have to be careful about the order that we put questions in. Sometimes an answer to a previous question can make people respond to the next question slightly differently. So we can actually make a question a loaded question based on the answer to the question that we gave them above that question with a previous question. Right. Non-response is an issue. People will skip questions when we ask, or they might refuse to answer. And it matters when people choose not to respond. Sometimes it's a mistake, but most of the time it's because they don't feel comfortable answering that question, or they don't feel strongly about something, or any number of other things. All right? Non-response is something that we shouldn't necessarily ignore, and depending on the context, we need to treat it differently. Finally, percentages. Percentages are incredibly important in statistics and in life really in general. They're misused and abused constantly. 100% is all of something. When someone says that something is 120% off in a sale, that means they should be paying you to take their product. Guaranteed they're not. All right? So percentages, whenever you see them in something, be careful and make sure you understand how they're truly being used and what's happening. And when you're referencing percentages, be careful that you're not misleading people as well.